My name is Oscar Gomez and I'm going to show you a methodology for the strategic planning of PMU placement in electric power grids. Initially, let me introduce the electric power system with generators, transmission line, and several buses. The system operator, who has to monitor and control the system, and the PMU, which is the device to measure voltage, current, and several electrical parameters that the system operator will use to monitor the system.
I'm sorry, I'm interrupting you.
Oh, sorry. I have it. Well, the first problem for the system operator is to select the buses where the PMU will be located. So we can solve that problem by using an optimization problem. I'm going to show a little bit about the optimization problem, but I am not going to explain the model. The idea is to minimize the number of PMU that I have to place in the system to monitor all the systems. It is not necessary to put a PMU in each bus, because if I place a PMU in this bus, I can monitor this bus and this bus too. So the idea is to minimize the number of PMU considering that constraint. Well, for this system, which has 69 buses, you can see the number of possible solutions for the problem. As you can see, it's a big number. And the solution for that system is 24 PMU. You can find that solution, but the problem is, can you imagine how is the number of PMU and how is the number of solution for a system with 1,000 of buses? For example, Colombia. Right now, I am working in Colombia and I have that problem. That's why we are proposing a new strategic planning for the PMU placement in the power system. In order to show a methodology, I'm going to show that flow chart. The flow chart has two parts. The first part is the PMU placement for inter-area observability. What's that? The idea is to monitor different areas in the system. For example, monitor the coast in Colombia and the center in Colombia, and see what happened between those two areas. The second part is the PMU placement for intra-area observability. And that means monitor only a specific area in the system. And the third part is to put the PMU that are necessary to get full observability of the system. So methodology will show, will place the PMU and a methodology. I forget the word. The idea is that the methodology we can find where and how to place those PMU. Well, the first part, the first stage is the PMU placement for inter-area observability. So the steps are initially to build an equivalent graph with the only generators of the system and identify the coherent generators to put a PMU and monitor those generators. What means coherent generators? Suppose that we have a group of generators. Yes? We have 5 generators and we have another 5 generators, and the system is operating normally. So generators are swinging together. But if something happens in the system, those group of generators cannot oscillate against each other. That means they are oscillating, but one is in one direction and the other one in another direction. So we have to identify those coherent generators and then obtain a place in that area to put the PMU. Finally, by solving the shortest path problem, the idea is to get the central vertex in each area, and that would be the place to put the PMU. That is the first part of the flowchart. The second stage is the PMU placement for inter-area observability. In this stage, we are going to solve the optimization problem that I showed at the beginning, but in a small system. So it's easy to solve that problem, considering that some PMU will be in the system due to the first part of the methodology. And the third part is to find the PMU location for the rest of the system that is concerned in this moment. Here you can see that it is an iterative process that will be done in the system to identify buses that have high centrality in the system. That buses will be the place to put the PMU. For the system that I showed at the beginning, this is the solution by using this methodology. You can see that it's 28 PMUs. Do you remember the first solution? It was 24, exactly. So it is now very far of the optimal solution, and it's a strategic planning for the PMU placement in the electrical power system. So, any question?
For the previous slides, there are some kind of hierarchy of the PMUs in the network, or around in the same level?
Okay, if I want to monitor the system, all the PMU is the same, but in this methodology, some PMU are more important than the other ones, because I have some PMU to monitor, for example, inter-area problems. So those PMU are specialized for that.
Your final results show that there were the 28,
Yes.
and at the beginning was 24. What's the difference with that?
Because when I am solving the optimal problem, I am avoiding the problem by using all the system. With my methodology, the idea is some stage, but to find some special regions in the system. So it's not see all the system. It's like to divide the system in some parts and monitor different parts of the system. At the end, I will be more PMUs than the optimal solution. But it is not very far of the optimal solution.
But what's the advantage of placing more PMUs?
Okay, see, if I have this is the optimal solution for that system. Yes, the question is, initially, what is the first PMU that I have to put in the system? I don't know. Second, if I want to monitor all the system, I have to place all the PMU in the system. I don't have enough money to put that PMU. Also, I have to improve the substation. I need a communication network to manipulate all of the information that PMU management. So that's why it is to identify a methodology to put PMU one by one, for example.
I don't know if I get this very well. This is a solution,
Yes.
an ultimate solution.
It's an ultimate
And the other one is with your methodology.
Exactly.
And you say that this is the optimal solution.
For this problem, for this system, yes.
With what kind of methodology you use in order to get this solution?
Integral linear programming, for example.
Okay.
How important is to obtain a solution
an optimal solution for that kind of problem? I mean, it's not a dynamic system.
Yes, actually the optimal solution is not very important because the problem is what are going to do with those PMU in the system. That is the problem that Colombia has in this moment. For example, they have some PMU in the system. They only have 7 PMU, but they don't know what to do with those PMU. Well, thank you very much.